So this video, we're going to show the answers to your limiting reactance problems. In this first one, we have 15 grams of iron bromide and potassium chloride, and we want to know which makes more. When you do limiting reactants, you have to set up the problems with both of them, and so that's exactly what we're going to do. We got 15 grams of iron bromide. I'm just going to start with that. We need grams of iron bromide to the bottom, moles of iron bromide to the top. We're going to go gram to gram on all of these. That's going to be 3 conversion factors because we're crossing 3 arrows, and the first arrow is grams to moles of the first substance. When you have a moles to grams conversion, it's always 1 mole to the molar mass. So 1 iron plus 2 bromines, I got 215.65. Grams of iron bromide are going to cancel out. We're left with moles of iron bromide. So moles of iron bromide are going to go to the bottom of the next one. The next term we're going to do is moles to moles. So we're going to have moles of one substance to moles of the other substance. And so our other substance is KBr, because we want to know how many grams of KBr we make. Whenever it's a mole to mole ratio, now we're going to pull the numbers from the chemical equation, which is 1 to 2. So we bring in 2 moles of KBr from this 2 coefficient out in front and 1 in front of FeBr2. That's going to cancel out moles of FeBr2. We are now to our new substance KBr. Moles of KBr to the bottom to cancel. We want to go to grams because up in our helper tool we're going moles to grams. In our third term, 1 mole to the molar mass, 119. In your calculators, you type in 15 divided by 215.65 times 2 times 119, and I got 16.55 grams of KBr being made. Now you do the exact same thing with the KCl. So this time we're starting 15 grams of KCl. So grams of KCl on the bottom, moles on top. The mass of KCl is 74.55 from the formula weight. Moles of KCl to the bottom, moles of KBr on top, because this is our mole to mole conversion. When you're mole to mole, you have to go to your chemical formula. So there's a 2 in front of KCl, and there is a 2 in front of KBr. So both of them get 2's this time. So this middle term is just 1. We don't have to calculate it. Last term, moles of KBr are going to be left because moles of KCl are canceling. So moles of KBr to the bottom, grams of KBr on top because we're going moles to grams. Anytime you have moles to grams, it's 1 mole to the molar mass. We've already done this part, so notice how these 3 terms, the top, middle, and the end, are always the same because we're always calculating mass of KBr. So it's only the beginning 3, the first 2, and then the bottom in the middle, that you change depending on your substance. In your calculator, 15 divided by 74.55 times 2 divided by 2, or simply skip that step, multiply by 119, I got 23.96 grams of KBr. So, how much do we actually get? Well, our limiting reactant is going to be FeBr2. We ran out of it first, so we're going to make the least amount. So I only have enough FeBr2 to make 16.55 grams. Problem 2. Again, we're going to be going gram to gram on all of these, although technically, you could stop at this middle term and find out how many moles of each get made, and whatever's the lowest amount is going to be your limiting reactant. But you still have to convert that to grams because it says which will make more. This time it's going to be uranium and bromine. We have 30 grams of uranium, 40 grams of bromine, and we want to know what the limiting reactant, the excess reactant, and the theoretical yield. Well, the theoretical yield is going to be whatever the limiting reactant gives us. I'm going to start with uranium. 30 grams of uranium, so grams of uranium to the bottom, moles on top. Mass of uranium is 238.03. Moles of uranium to the bottom, moles of uranium bromide to the top. And since it's a mole to mole, we got to go to our chemical equation, so 1 goes with U and 1 goes with UBr6. Moles of UBr6 to the bottom, grams on top, and when it's moles to grams, it's 1 mole is equal to the molar mass. 717.45 is what I got. So in your calculator, 30 divided by 238.03 times 17.45, I get 90.42 grams of UBr6. Run the exact same thing with bromine. So this time we're starting with 40 grams of bromine, and we're going to convert it. The term on top, the term on the bottom, and this term on the bottom is going to change because now this is all going to change to bromine. So moles of bromine, the grams of bromine, 1 to the molar mass of 159.81. Moles of bromine to the bottom, moles of UBr6 to the top. So this time we have moles of UBr6 is 1, and moles of bromine is this 3 right here. So it's 1 to 3. Next term, moles of UBr6 to the bottom, it's going to look exactly like this. You just copy what you already got, because that stays the same. 40 divided by 159.81 divided by 3 times 717.45. Even though I started with a heavier amount of Br2, that is my limiting reactant because that's the least amount. So the bromine is my limiting reactant, the uranium is my excess reactant, and I'm going to make 59.86 grams of UBr6. Problem number 3. You've got ammonia, you've got oxygen, you've got 100 grams of each. How much water are you going to make? What is the limiter? What is the excess? Start with 100 grams of NH3. So grams of NH3 on the bottom, moles of NH3 on top. 1 mole to the formula weight for NH3, 14.04. 1 mole of NH3 on the bottom to moles of H2O. Well, this time it's going to be 4 with the NH3 and 6 with the H2O. Moles of H2O to the bottom, grams of H2O on top. That's going to be 1 to 18.02. 100 divided by 14.04 times 6 divided by 4 times 18.02. And I get an answer of 192.52. And I'll bring in my calculator here so that you can see how I entered it. 100 divided by 14.04 times 6 divided by 4 times 18.02. You just plug it in just like I say. Our next one, 100 grams of oxygen. So set up our first conversion factor, grams of oxygen to the bottom, moles of oxygen to the top. That's going to be 1 to the molar mass of oxygen. Mass of oxygen is 16, but there's 2 of them. That's 32. Moles of oxygen to the bottom, moles of water to the top. The number that went with moles of water is still 6, and from oxygen is 5. Next term, moles of water on top, and it's going to look exactly like the last term. You're just copying it, 18.02. So on this one, 100 divided by 32 times 6 divided by 5 times 18.02. I got 67.58 grams of water. And here again, I'll bring this in. This is what I typed into my calculator. 100 divided by 32 times 6 divided by 5 times 18.02. 67.58 grams. That's excess reactants.